In this video, we will be looking at Chapter 8, Plane Geometry, and we'll be looking some more at triangles, hexagons, and irregular polygons. And we're going to be, we've already identified polygons, used the Pythagorean theorem, and looked at the area and perimeter is what we'll be doing with this section here. And so we're going to look at the area of a triangle, and the area of a triangle uses the simple formula: area equals 1/2 base times height. And you can see that that can also be written area as base times height over 2. Importantly, the base and the height are where you find the square of the triangle. And so wherever the triangle is squared, that's where you're going to find your base, where your base and height meet. And so it's important because if you turn this triangle over on its side, you still need to be able to find the base and height. Even though it might look like it's on the side, we still call it the base for the formula purposes. So when we're looking at a problem like this, we're going to go ahead and solve for the base and height, and you can see right here that the height is 12 centimeters, and which is over here, and the base is 20 centimeters, and that's over here. And so if we take and plug in the formula, and you can go and try this on your own if you want to stop the video. Okay, we're going to plug these numbers into our formula, and that is area equals 1/2 base times height, and so base times height, and so we have area equals base of 20 times 12 over 2, and 20 times 12 gives us 240. Divided by 2, which gives us 120. Now notice that this is an area problem, so you might have already caught it, and the units will be centimeters squared. So let's look at a different kind of triangle. This is called an isosceles triangle. We have two lengths that are the same. And so if we need to find the area of the isosceles triangle, one of the things that you might see immediately is that you don't have a height. But that's okay, because we can go ahead and use the Pythagorean theorem formula, which is what we learned in the last video. So you can go back and look at that again to be able to find the height of the triangle. So we're going to find the height of the triangle by using the Pythagorean theorem, and we're going to use the formula a equals c squared minus b squared. And we'll go ahead and substitute in because we don't know. In this case, we'll call this a over here, and that's our height, and that's what we don't know. And so we'll go height equals the square root of c squared, which if you remember is always the hypotenuse, 9 squared minus b squared, which is, that's our base down here, is just 3. And so we have 9 squared is 81 minus 9. So the square root of 81 minus 9. And so square root of 72 is 8.4. And I'm going to close that down, it's not responding. Okay, and so the square root of 72 is height of 8. Okay, and so because we're going to use 8 because that's the number of significant digits that we have rather than 8.4. And so now that we have the height of 8, we can say, okay, go back to the original problem, and we'll say, okay, 8 is our height. We want to be able to find the area, of the triangle, and remember, area equals 1/2 base times height, and so we'll substitute in our base of 3 times our height of 8 divided by 2, and so we have 24 divided by 2. Area equals 12, and in this case it is inches squared. Okay. So looking at this problem, we can go ahead and use this to find different things that we use calculate area for. Go ahead and try this one on your own using the information we've had, and then we'll work it out together. Okay, let's go ahead and try to work this problem out. So if we're looking at tiling the floor in this rectangular space, we know that we're looking for, we need to find the area so we can find out what that square footage cost is going to be. And so go ahead then and calculate the area of the triangle. So area equals 1/2 base times height, and so in this case area equals the base of 16 times the height of 8 over 2, and so we're going to have the area equals 16 minus 8, which is 8 over 2, which equals, area is 4 feet squared. And so now that we know the square footage of this, then we need to go ahead and multiply it by the cost of the floor. And fortunately the floor is sold per square foot. And so we can say, all right, it's 4 square feet times $3.95. And is $15.8 or $15.80. Okay, all right, go ahead and look at the next one then. So looking at irregular polygons, trying to find the perimeter and the area. The perimeter is pretty easy. Remember, perimeter, you just go along the outside and add up all the numbers, and that will give you the perimeter of an irregular polygon. The area is going to be a little bit more challenging, and only because you have to really divide this up into, and you need to think about it geometrically, shapes that you can find the area of. And so we know how to find the area of rectangles. That's length times height. And so we can look at this by dividing this up right here, and we can have actually two different rectangles, rectangle 1 and rectangle 2. You see the Roman numerals. And rectangle 1 will be 22 feet by 6 feet. And that's length times width, and we can get the number for that. And then we see for rectangle 2, it's 13 times, well, not really sure of what this side is, but we do see that this side over here is, since the length, the full length is 22, and this part of it that's right across from it is 10 feet. We can say, okay, off of the 22 feet here, we take 10 feet off here, which leaves us with 12 feet over here. So we can say, okay, the second rectangle is going to be 13 feet times 12 feet. And in that case, we go ahead and get the calculations for both of those, and it comes up to be 288 inches squared. Now there's another way to do this too, and it's looking at the using the subtraction method. And so some people are better at this than others. Some people, when they look at this, I found a lot of people that are good at art can see this, because it's has to do with empty space, and the necessity of empty space is an important concept when doing art. And so they look at this as a whole rectangle in which they're needing to get rid of that space so that they can find out what the area is of this space. So it's the whole space minus the space that's missing. And so to be able to do that, it's very similar to what we did in the other one. So you look at this and you say at the whole rectangle, and you say, okay, it is 22 feet tall, and then it is, let's see, it's 6 feet here and 13 feet here, so altogether that's going to be 19, so it's 22 times 19. And then the space that's missing is, well, there's 10 foot of space missing here, and there's 13 feet missing here, and so then that's going to be 130 inches, so you just subtract from the larger rectangle and you subtract the smaller rectangle, and you end up with the area of the rectangle that is the irregular polygon. Now, sometimes, as much as you want to try to add a couple different geometrical figures together to get the answer that you want for an area, you just can't do it because they don't give you the information. So if you look at this problem over here, you can see that they give you the distance from D to B is 10 feet, and the distance from B to C is 6 feet, and then across the bottom is 33 feet. Now, that doesn't do you any good when you're trying to figure out what these distances are here, because you don't have a right angle to be able to go off of for these distances to get the remainder of that, how long that is. So what you need to do is you need to look at this as it is one large figure and calculate the large figure and then subtract off the smaller figure. And that's how to find the area for the triangle that they have, or the shape that they have highlighted there. And then in some problems, you'll have it to where there is a problem that intentionally has missing space to it. Now, what you want to do is you want to look at and subtract the space out of one polygon from another. And so go ahead and try this one on your own first, and then we'll work this one out together. Okay, we're back, and so let's look at first then, there is a larger polygon here. And we are going to use this trapezoidal shape to remember that our formula for finding the area of a trapezoid is the area is the base plus the height over 2, or excuse me, the base of one plus the base of the other one over 2 times the height. We're also going to remember that with a trapezoid that the bases are the two parallel edges, and so we need to make sure to remember that. And so let's go ahead then and we'll use this. The area of the larger trapezoid, and that's why I have A sub L, is the one base, 6, plus the other base, 9, over 2 times the height, which is, in this case, 9, rather than H. We'll go ahead and substitute that in. And this is 15 over 2 times 9, so 30 times 9, excuse me, not 30, sorry, 7.5 times 9, and that's 67.5, and that's in inches squared, and that is for our larger polygon. So this is A sub L. So now let's go ahead and look at the smaller polygon. And so I'm going to do this one over here. The area for the smaller, it's the same formula. So base 1 plus base 2 over 2 times the height. And the smaller polygon is 4 feet plus 6 feet over 2 times 6 feet is the height. And we're going to say 4 plus 6 is 10 over 2 is 5 times 6 is 30 inches squared. And so that is for A sub S, the smaller one. Now if we take AL minus AS, and so we have 67.5 minus 30 is 37.5 inches squared is the amount of space that is in here, because that's what we're going for. We subtracted the larger polygon, the smaller polygon from the larger polygon. And so now, sorry about that, I had somebody at my door. And so remember that the problem is looking at finding the cost in it's per square foot for the for this unit. And by the way, looking back at that, these units are feet squared, not inches squared, which we could have worked out, but it's a lot easier since the units match. And we know then that we have 37.5 square feet times $6.75 per square foot. And so 37.5 times 6.75 is $253.13. Okay, and that is the end of this unit.